Chapter 2. Is matter around us pure? How do we judge whether milk, ghee, butter, salt, spices, mineral water or juice what we buy from the market are pure? Have you ever noticed the pure word written on the packs of these consumables? For a common person, pure means having no adulteration, but for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually mixture of water, fat, proteins, etc. When scientists say that something is pure, it means that all the constituents particles of the substances are the same in their chemical nature. A pure substance consists of a single type of particle. In other words, a substance is a pure single form of matter. As we look around, we can see that most of the matter around us exists as mixture of two or more pure compounds. For example, seawater, minerals, soils, etc. are all mixtures. Now, what is a mixture? Mixtures are constituted by more than one kind of pure form of matter. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by a physical process into its chemical constituents. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is the same throughout. Soft drink and soils are not pure substances. Whatever the source of a pure substance may be, it will always have the same characteristic properties. Therefore, we can say that a mixture contains more than one pure substances. Now, the type of mixtures. Depending upon the nature of components that form a mixture, we can have different type of mixtures. Let us discuss activity 2.1. Let us divide the class into group A, B, C and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate powder. Group B takes 50 ml of water and two spatula full of copper sulfate powder in a beaker. Group C and D can take different amounts of copper sulfate and potassium permanganate or common salt, which is sodium chloride, and mix the given components to form a mixture. Report the observation on the uniformity in color and texture. Group A and B have obtained a mixture which has a uniform composition throughout. Such mixtures are called homogeneous mixtures or solutions. Some other examples such as mixtures are salt dissolved in water and second, sugar dissolved in water. Compare the color of solutions of the two groups. Though both the groups have obtained copper sulfate solution, but the intensity of color of solutions is different. This shows that a homogeneous mixture can have a variable composition. Group C and D have obtained mixtures which contain physically distinct parts and have non-uniform compositions. Such mixtures are called heterogeneous mixtures. Mixtures of sodium chloride and iron fillings, salt and sulfur, and oil and water are examples of heterogeneous mixtures. Let's discuss activity 2.2. Let us again divide the class into 4 groups A, B, C and D. Distribute the following samples to each group. Few crystals of copper sulfate to group A, one spatula full of copper sulfate to group B, chalk powder or wheat flour to group C, few drops of milk or ink to group D. Each group should have given sample in water and stir properly using a glass rod. Are the particles in the mixture visible? Direct beam of light from a torch through the beaker containing the mixture and observe them the front. Was the path of the beam of light visible? Leave the mixture undisturbed for a few minutes and set up the filtration apparatus in the meantime. Is the mixture stable or do the particles begin to settle after some time? Filter the mixture. Is there any residue on the filter paper? Discuss the result and form an option. Group A and B have got a solution. Group C has got a suspension. Group D has got a collider solution. Pause the video and check out the figure about the filtration. Now we shall learn about solutions, suspension and collider solution in the following section. These are the questions. You can read and answer it by yourself. 2.2. What is a solution? A solution is a homogeneous mixture of two or more substances. You come across various types of solution in your daily life. Lemonade, soda water, etc. are all examples of solutions. Usually, we think of a solution as a liquid that contains either a solid, liquid, or a gas dissolved in it. But we can also have a solid solutions alloy, gaseous solution, which is air. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. More to know. Alloys. What are alloys? Alloys are mixture of two or more metals or a metal and a non-metal and cannot be separated into their components by physical method. But still, an alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. For example, brass is a mixture of approximately 30% zinc and 70% copper. A solution has a solvent and a solute as its component. The component of the solution that dissolves the other component in it. Usually, the component present in a larger amount is called the solvent. The component of the solution that is dissolved in the solvent usually present in lesser quantity, and that is called the solute. Here are some examples. Example number 1. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is a solute and water is the solvent. Example 2. A solution of iodine in alcohol known as tincture of iodine has iodine as the solute and alcohol as the solvent. Aerated drinks like soda, water, etc. are gases in liquid solution. These contain carbon dioxide as solute and water liquid as solvent. Air is a mixture of gas. Air is a homogeneous mixture of a number of gases. It has two main constituents, which are oxygen, which is 21%, nitrogen, 78%. The other gases are present in very small quantities. Let's see the properties of a solution. A solution is a homogeneous mixture. The particles of the solutions are smaller than 1 nanometer, that is 10 to the power minus 9 meter in diameter. So they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is a solution. A solution is stable. Now let's discuss concentration of a solution. In activity 2.2, we observe that group A and group B obtained different shades of solution. So we understand that in a solution, the relative proportion of the solute and solvent can be varied depending upon the amount of solute present in the solution. It can be called dilute, concentrated, or saturated solution. Dilute and concentrated are comparative terms. In activity 2.2, the solution obtained by group A is dilute as compared to that obtained by group B. Let's discuss activity 2.3. Take approximately 50 ml of water in each two separate beakers. Add salt in one beaker and sugar or barium chloride in the second beaker with continuous stirring. When no more solution can be dissolved, heat the contents of the beaker to raise the temperature by about 5 degrees Celsius. Start adding the solute again. Is the amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature the same? At any particular temperature, a solution has dissolved as much solute as it is capable of dissolving is said to be saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature is called saturated solution. The amount of solute present in the saturated solution at this temperature is called its solubility. If the amount of solution contained in a solution is less than the saturation level, it is called as unsaturated solution. What would happen if you were take a saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. The concentration of a solution is the amount of solute present in a given amount of solution. There are various ways of expressing the concentration of a solution, but here we will learn only 3 methods. First, mass by mass percentage of a solution, which is equals to mass of solute divided by mass of solution multiplied by 100. Second, mass by volume percentage of a solution equals to mass of solute divided by volume of solution multiplied by 100. Third, volume by volume percentage of a solution is equals to volume of solute divided by volume of solution multiplied by 100. So pause the video and try to solve this question. Example 2.1. Okay, let's move to what is a suspension. Non-homogeneous system like those obtained by Group C in Activity 2.2 in which solids are dispersed in liquid are called suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Properties of a suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter anymore. So let's move to what is a colloidal solution. The mixture obtained by Group D in Activity 2.2 is called a colloid or colloidal solution. The particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particle as compared to that of the suspension, the mixture appears to be homogeneous, but actually a colloidal solution is a heterogeneous mixture. For example, milk. Because of small size of colloidal particles, we cannot see them with naked eyes, but these particles can easily scatter a beam of visible light, as observed in Activity 2.2. This scattering of beam of light is called the Tyndall effect, after the name of scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to scattering of light by the particles of dust and smoke in the air. Pause the video and check out the diagram. Let's discuss the Tyndall effect. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water which act as a particle of colloid dispersed in air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen with the naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of a dispersing medium and the dispersed phase. A few common examples are given in the table 2.1. From this table you can see that they are very common everyday life. So pause the video, check out the table for better understanding. 2.3 Physical and chemical changes. In the previous chapter, we have learned about a few physical properties of matter, the properties that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc. are the physical properties. The interconversion of states is a physical change, because these changes occurs without a change in composition and no change in the chemical nature of a substance. Although ice, water and water vapor all look different and display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air whereas water extinguishes fire. It is the chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings the change in the chemical properties of a matter and we get new substances. A chemical change is also called a chemical reaction. During burning of a candle, both physical and chemical changes takes place. Can you distinguish this? Pause the video, check out the questions for better understanding. 2.4 What are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. 2.4.1 The elements. Robert Boyle was the first scientist to use the term element in 1661. Antoine Laurent Lavoisier, a French chemist, was the first to establish an experimentally useful definition of an element. He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reaction. Elements can be normally divided into metals, nonmetals, and metalloids. Metals usually show some or all of the following properties. These properties are: they have a luster shine, they have silvery gray or golden yellow color, they conduct heat and electricity, they are ductile, which means can be drawn into wires, they are malleable, can be hammered into thin sheets, they are sonorous, make a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Non-metals usually shows some of or all of the following properties, which are: they display a variety of colors, they are poor conductors of heat and electricity, they are not lustrous, sonorous, or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and nonmetals. They are called metalloids. Examples are boron, silver, germanium, etc. More to know. The number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, which is mercury and bromine. Elements like gallium and cesium becomes liquid at temperature slightly above the room temperature. Let's discuss the compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. What do we get when two or more elements are combined? Let's discuss the activity 2.4. Divide class into two groups. Give 5 gram of iron filling and 3 gram of sulfur powder in a china dish to both the groups. Group 1. Mix and crush iron fillings and sulfur powder. Group 2. Mix and crush iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Group 1 and 2. Check for magnesium in the material obtained. Bring a magnet near the material and check if the material is attracted toward the magnet. Compare the texture and odor of the metal obtained by the groups. Add carbon disulfide to one part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to the other part of the material obtained. Note: teacher supervision is necessary for this activity. Perform all the above steps with both the elements, iron and sulfur, separately. Now pause the video and answer the questions. The gas obtained by the group 1 is hydrogen. It is colorless, odorless, combustible. It is not advised to do the combustion test for hydrogen in the class. The gas obtained by group 2 is hydrogen sulfide. It is a colorless gas with a smell of rotten eggs. You must have observed that the products obtained by both the groups show different properties though the starting materials were same. Group 1 has carried out the activity involving a physical change, whereas in case of group 2 a chemical reaction has taken place. The material obtained by group 1 is a mixture of two substances. The substances given are the elements, which is iron and sulfur. The properties of the mixture are the same as that of its constituent. Pause the video. Observe the table 2.2 mixtures versus compounds. for better understanding. The material obtained by group 2 is a compound. On heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. The composition of a compound is the same throughout. We can also observe that the texture and the color of the compound are the same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organizer. Pause the video and observe the graphical organizer. So, let's discuss what you have learned. A mixture contains more than one substance, elements, and or compound mixed in any proportion. Mixture can be separated into pure substances using appropriate separation technique. A solution is a heterogeneous mixture of two or more substances. The major components of the solution is called the solvent and the minor the solute. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. Materials that are insoluble in a solvent have properties that are visible to naked eyes, form a suspension. A suspension is a heterogeneous mixture. Colloids. Colloids are heterogeneous mixture in which the particle size is too small to be seen with the naked eye, but is big enough to scatter lights. Colloids are useful in industry and daily life. The particles are called the dispersed phase, and the medium in which they are distributed is called the dispersion medium. Pure substances can be elements or compounds. An element is a pure form of matter that can be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements chemically combined in a fixed proportion. Properties of a compound are different from its constituent element, whereas a mixture shows the properties of its constituting elements or compounds. Pause the video and check out the exercises. Try to solve them by your own. Thanks for watching.